Okay, welcome to your Unit 9 project. This is a little game where you're going to be taking your blue player rectangle and attempting to avoid all the other color enemies and reach the green goal. This project has been set up for you already in Replit, as you can see here. So I will be sharing this project with you. You'll fork the project and then continue working on it on your own. So what I'm going to do in this video is I'm going to walk you through um, just getting things set up and starting the project and going through the answers in this document to make sure you understand what's going on. So we're going to be using rectangle objects in this program. Each of these uh, squares here is a rectangle object. And rectangles are a part of the Java language, so you won't see the rectangle class in the actual project itself. So part 0 here, I've already done for you. I've already set it up on Replit, so we don't need to worry about that. We're going to go into part 1 and part 2, and there is a quiz on Canvas that I'm going to have you take, and I'm going to basically give you all the answers to that quiz right here, okay? But I want to make sure that you take that quiz yourself so that you understand what's going on as you start working on this project. So, in our setup here, we have different kinds of enemies. Spinning enemy, stalker enemy, vertical enemy, and you're going to be writing the code for all these enemies that are going to be trying to get in the way of our player rectangle. So the vertical enemy is going to be going up and down. The diagonal enemy is going to be going diagonal, kind of bouncing in this kind of pattern here. The spinner enemy is going to be going a circle. And then the stalker enemy is actually going to chase you as you move around. So all these enemies are enemies. They're different kinds of enemies, but we have this superclass enemy, and then it is going to be the parent class of all the subclass enemies. So you can see the spinning enemy has already been written, and it extends enemy because it is a subclass of enemy. So why? Why do we have a superclass enemy? Multiple reasons. But you can see the methods that the enemy class has and the instance variable that the enemy class has. So this is where the rectangle is stored that visually represents the enemy. Enemies have a color. You can get the rectangle that represents that enemy, and that's for determining whether two rectangles collide. There is the actual collide method that we'll be calling. There is a move method that doesn't have any code in it. Interesting. And then there's a draw method that has the graphics aspect in it. So the graphics part is really simple. It's just you have a graphics object that you paint with. So it's similar to when we use like a pen in Scratch. You can set the color of the pen. The pen is the G. You can set the color of it, and then you call g.fillRectangle, and then you use the coordinates and size of the enemy's rectangle to fill a rectangle of that size. And this draw method is going to be called just all the time, just constantly getting called. Draw, 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 because it's like a frame rate where it just constantly updates the graphics part of the program. All right, so we're going to get started with part 1, walking through the answers to these questions. And again, go take the quiz on Canvas, the part 1 and part 2 quiz. All right, so look at the obstacle game class. The obstacle game class is where all the game code is located. And the first question is how many fields does the obstacle game class have? So we're going to count those up and go through those. So here's the obstacle game class. It has the most code in it of all the classes because it's where all the action is happening. So first of all, the obstacle game is a JPanel. The JPanel is just part of the graphics. It's just a window essentially to put stuff in. It implements a couple of interfaces. We're not learning about interfaces, so you don't really need to worry about those very much. All right, the question was how many field variables does this class have? So they're all listed right here. There's a rectangle representing the player. There's a rectangle representing the green goal. There is a set of enemies, and this is really the key part for our Unit 9 here, is we're going to have an array of enemies. What kind of enemies are we going to put in here? All of them. We're going to put all the enemies into this one enemy thing so that we can constantly be updating those enemies down below. We have 4 different Boolean variables keeping track of which keys are pressed. There's a timer. The timer is, the purpose of that is to tick basically for the frame rate. And then there are 2 variables for the width and height of the window. So how many field variables do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 field variables. There we go. All right, how large is the array of enemy objects? As you saw there, we're going to have 4 enemies right there. And then the next question, what command makes the player move 3 pixels to the right? Okay. All the movements things are in the key press event. Sorry, the key press event just keeps track of whether you're holding down keys. So the actual movement doesn't occur there. This is just updating those 4 Boolean variables. And then when you release the key, it sets those variables to false. But the actual movement occurs in the update method down here. So this update method is what's getting called all the time. It's in control of movement and drawing. So can you tell from here which command moves the player to the right? So obviously it's checking that right Boolean variable to see if the right key is being held down. And then we do player.x plus equals 3 as the command. So that's the answer to that question, that line right there. You should see enemy objects being used throughout the code. There are 3 methods of the enemy class that are being used. What are those 3 methods? This one's a little bit harder to find, so I'm going to go through this one pretty carefully. All right, so the enemy class again has methods draw, move, intersect, get rectangle, get color. And we're supposed to identify the 3 that are being used in the obstacle game class. Let's see what those are. Down here in Paint, which gets called all the time to repaint the screen, we have a bunch of graphic stuff, and then, oh, look at this. For each enemy, we call the draw method. So that's one of them. Draw. Then I see some more right in here. So this is back in that update method where we were moving the player around. We have to check to see if the player is intersecting the goal. In that case, U1. And then again, we have a similar for loop, that enhanced for loop that goes through the array of enemies. It doesn't matter what kind of enemy they are, they're all going to be doing the same thing. Does that enemy intersect the player? If it does, you lose. And then the enemy is always moving. How is that enemy going to move? That is up to the type of enemy. Do you see this is the big Unit 9 thing right here? Using inheritance, we can call move on all the enemies. They're all going to move in different ways. But we don't have to individually call separate move methods. We just call move, and then however that enemy is programmed to move, it will move. So that's the polymorphism is what's going on there. So the other two methods were intersects and okay. What are the 5 methods of the enemy class? And then you're going to categorize them as accessor, mutator, or something else. I've already been through those 5 methods a couple times, so you can list those. Accessor means it's getting information, so you'll see the word get in the name of the method. Mutator means it's changing some property of the enemy, and then something else is if it does neither of those things. How many fields does the enemy class have? Let's check it out. The enemy class has just one. It's just the rectangle. Okay? That rectangle then is in charge of storing its location and size, which we can access when necessary. So the x, the y, the width, and the height, those are not fields of the enemy class, they're fields of the rectangle class. The enemy class just has one field. The enemy class has one constructor. What is the parameters? We tell it the position and the size that it's going to be. And then when we construct the rectangle, it just uses those to pass to that rectangle class. What does the enemy do with the parameters? As I just said, it constructs a rectangle using them. And then what does the enemy class's move method currently do? And the answer to that is nothing, because we are going to override that move method in each class. Okay? All right, so that was your introduction to the obstacle game project. Next up will be for you to program the vertical enemy. Okay, so this is where you're going to get into overriding that move method because vertical enemies actually have to move. All right, I'll be posting another video to help you out with that, and then the rest of the project will be on your own. You'll just follow along with this document and complete the project. Okay, so it's just going to be a matter of programming 3 different enemies and getting those to work.